So we have a problem, which is also an opportunity at ThinkMill quite often, which is we need to run Node, and it needs to run on a platform. And it's not a platform we control. It might be a platform we know and love. It might not be. It really might not be. But all the same, we have to run, usually on Windows, some Node stuff. And the reason we're doing that is because we're adapting with some old thing that uses files on a Windows machine, and we want to make it talk to the cloud in a nice way. We write in Node, so it's easier if that app is in Node. So we want to get that on that machine. So we have a few options for doing that I'm aware of. I'd love to hear others if other people know, but these were the ones we evaluated. You can use Node directly, which is supported. You can use a VM to run your Node process. You can use Docker, or maybe something else that might have been slightly alluded to by my title. So if you use Node directly, it's great because it's supported and you get direct access to the system. But what we found is there's just a heap of stuff to install and configure. To be able to do updates, you're going to want to install Git. So then you've got the Unix shell thing happening there. You also have to install your yarn and then get all your dependencies set up. And basically, you're hacking around with this. The user can't tell what's going on. They can't debug it. They don't know where the logs are. They don't know how to run it. It's non-containerized, so all of your dependencies aren't brought along for the ride. So if you want to update a version, well, now you need to remote in the machine and go in and update things. Basically, it becomes a dev box that you maintain. And when you have 70 of these, it's a bit of a problem. So we could do a VM. And what that lets us do is it lets us get our POSIX system back, which I know you can do in Windows kind of, but that would be even more confusing for users in my mind. Lets you update a single file, which updates all your dependencies. Problem is there's still lots to install and configure because you have to run VirtualBox or Vagrant with that, all sorts of things. Users still can't interface with it. The VM images are huge. They can be fairly small if you use something like Alpine as an image, but it's still a pretty hefty thing to be downloading. Some of our machines that we're interfacing with are in South Africa. Connections aren't always the best. And configuring this is really a big pain because the reason we're on the Windows machine is because we want to interface with the file system from the Windows box. So now you're mapping files across and sharing folders. And again, how does the user even know or debug this? So Docker's nice because it's kind of like a VM, but it's a lot lighter. So let's just get Unix back again. We can update one file. It's lighter, but there's still stuff to install and configure. You still have to set up Docker. Thankfully, it runs natively on Windows now, but still have to do that. And the user still can't figure out what's going on. So this is kind of the common thread that I've got going through all three of these things. And I took a step back and went, OK, what is Electron? Well, it turns out Electron is a node process with a browser attached. So you guys might know some Electron apps out in the wild, like Slack or Atom. Effectively, they run a node process in the background and then let you use a browser in the front to actually see your UI. So if we approach it like, hey, node's inside Electron, it means we get direct access to the system. We can update a single file, which would be, in the Windows case, a .exe. The user can interface with it really easily because it's just a program they double click on. And that's pretty much it. You want to update it, you give them a new exe. The only downsides to it really are you're now actually running Node on Windows, so you have all the cross-platform issues with your code base if you haven't properly handled file paths and things like that. And it's not particularly easy to run as a service or a thing that happens in the background. It's really better for a foreground app. But in our case, that was fine. So when you're working on one of these apps, we use this really confusing folder structure. Main is where the node stuff goes. Window is where the browser stuff goes. And then there's kind of the config outside of that. So once you start digging into Electron, there's a whole bunch of APIs that go along with it. The main process gets apps to all that, kind of access to all that main process stuff. Renderer processes your browser. They are actually two separate programs, so it's important to keep that in mind. You're not actually dealing with the same code base. But you can access the clipboard from both and some things. But really, you don't need to worry about that too much because most of what you're communicating to the user is just, hey, I'm working, or I had a problem and here's the problem. So you don't have to do a particularly complex UI to enable that. So you can use Electron's IPC, which is inter-process communication, to talk between those things. This is what it typically looks like. So inside the browser, all you do is require Electron, grab the IPC renderer off of it, and then you just say, hey, whenever a log update comes in, please call me back and pass that to me. Then you can update your DOM however you want. You could even use jQuery if you feel so inclined, but you could use React or Angular. People use Angular, right? Then in the main process, you need to create your window. You load a URL, which is where you point it at the index.html, and then you can start sending events to it. And you literally just pass an array, and it'll pass that array to you on the browser side. So to run one of these things from a code base, do the usual things with Node. It's really simple. This is what it actually ends up looking like on Mac. So you get you can't really see it because it's tiny, but there's a little shirt icon up there, which is relevant to our use case. And we're getting logs now. And this is the entirety of our interface on the front end. But it lets them see that log's just kind of constantly updating, lets them see it's working. And if there's a problem, they can just copy and paste that to us. And we're good. They just double click it. So really now the only problem is, what if we're trying to build for Windows and we don't have a Windows machine? Isn't that going to be horrible to build? Kind of, but it doesn't have to be. There's a CI service called AppVeyor, which will run CI on Windows. So once we've configured that to build our Electron apps properly, it means our workflow is commit, push, exe comes out the other side 5 minutes later as an artifact, and we can download it from AppVeyor. So I feel like that's a pretty good solution to effectively use Electron as if you were trying to do Docker. So any questions?